Okay, on to the next question. Use your calculator to find the coordinates of any relative extrema and the function f of x is equal to x cubed minus x. And then use your calculator to graph the derivative of that function, find the zeros, and what connection is there between the extrema of f of x and the zeros of the derivative of the function. What rule has been illustrated by this? So let's first find the extrema of f of x. So we find the extrema by, so if f of x is equal to x cubed minus x, we find the extrema by taking the derivative first and setting it equal to 0. So this becomes 3x squared minus 1. And we like to set it to 0 and then test points before and after it, because when the derivative of whatever function is 0, that means we are at a maximum point. So we want to find out what the derivative would have looked like before. So if it's positive, it would be pointing that way. If it's negative, it'll be pointing this way, for example. So you'd get, for points less than 0, you should get the derivative is greater than 0, so it's positive. And for points above 0, you're going to get a negative if it was this function. So let's test out what our function is going to look like. So first, let's find those points. So we have 3x squared is equal to 1, which means x squared is equal to 1 over 3. And this leads to the conclusion x is equal to 1 over the positive and negative square root of 3. So let's test values before and after that. So, we have 2 points, 1 over square root 3, and negative 1 over square root 3. So to test points before this one, let's choose negative 2. Between these two, let's choose 0, and above this, let's choose 2. So testing negative 2, we get 3 by negative 2 squared minus 1. That's going to give us 12 minus 1, which is 11. So before our point 0, we're going to expect a positive. Next up, we check 0, and we get 3 by 0 squared minus 1, and that's just going to give us minus 1. So you expect a negative gradient. And then next up, we're going to test 2. So 3, 2 squared minus 1, that's again going to give us 12 minus 1, which is 11. So you expect another positive. So our function should look something along the lines of this. And we should be expecting this to be, this point where you have a turning to be negative 1 over square root 3, and the second point where you have another turning to be 1 over square root 3. So here we have positive, just as we expected, negative in between them, positive before. So this sketch is generally correct. Next up, let's find the zeros of this function. So we're going to need to find the derivative of that function, and that's just going to be equal to 6x, set it to equal to 0, and that's going to be at x is equal to 0. And so if we test points before and after, this is our turning point. Going to be our extrema. Our zeros are at 3x squared minus 1 is equal to 0, and so again we are going to get negative 1 over square root 3 and 1 over square root 3, which is the exact same points where we had the extrema here. So what this demonstrates is that the zeros of the derivative of the function are going to be the extrema of the function itself. And what this is demonstrating is the relation between zeros and relative extrema, but in functions that are derivatives of one another. And if we just quickly plot the two on Desmos, you'll see it a bit more clear. And so you can see that the turning point here, sorry, the 0 here is the turning point, and the 0 here is again the turning point. And that's it for this question.